applications of equilibrium constants. Second point is predicting the direction of a reaction. So, equilibrium constant is also used to find in which direction the mixture of reactants and products will proceed. That is, either the reaction takes place in forward direction or in backward direction. For this, first we have to calculate the reaction quotient. Reaction quotient Q. Okay, and compare this Q with equilibrium constant K. Equilibrium constant K. So, QC determines the reaction quotient with molar concentration, and QP reaction quotient with partial pressure. So, first we have to find QP or QC. How can we find QC? For a general equation. Consider the equation AA plus BB gives CC plus DD. This is a reversible reaction. Okay, so reactants and products. Either we have to first calculate Q with respect to molar concentration. QC will be equal to concentration of C, that is product raised to C, this stoichiometric quotient, okay, and D raised to D divided by A raised to A, B raised to B. Okay, so ratio of the product of the products, that is the ratio of the product of these products divided by the reactants, the product of the reaction. This gives QC. So from this reversible reaction, we can easily find QC. Also QP also we can calculate with respect to partial pressure. Now we have to compare this QC with K. This is the reaction quotient. If the equilibrium, first the reaction takes place either in forward direction or backward direction, and after some time what happens, an equilibrium is attained at which both forward and backward reaction becomes equal. So at this state the QC gets converted into KC, that is equilibrium constant. Okay, so if first case is if QC is greater than KC, what happens? If QC is greater than KC, then the reaction will proceed in the direction of the reactants. Okay, reaction will proceed in the direction of the reactants. That is, the reaction will take place in the reverse direction. Okay, reverse direction. Now, second case, QC will be less than KC. In such a case, the direction of the reaction will proceed in the direction of the products. Okay, direction of the products. Direction of the products means in the forward direction. Okay, so the reaction will take place in the forward direction. So from the value of QC, we can find either the reaction takes place in the forward direction or in the backward direction. Now the third case is QC will be equal to KC. In such a case, the reaction mixture is at equilibrium. Okay. Now, a problem based on this. That is, the equilibrium constant Kc for the reaction N2O4 gives 2NO2. It's a reversible reaction. Okay, is 0.36 at 373 Kelvin. That is, Kc is given. At a particular moment, concentration of N2O4 and NO2 in a mixture of 2 at 373 Kelvin is found to be 0.16 mole liter inverse and 0.2 mole liter inverse respectively. So the concentration of both reactants and products are given, that is N2O4 and NO2 are given. So from this data, first we have to find is this reaction at equilibrium. What will be the case? If the reaction is at equilibrium, QC we have to find. QC will be equal to KC. Next, if not, state the direction in which reaction will go. If the reaction is not at equilibrium, we have to find which direction the reaction will proceed. Okay, so for that, first we have to find QC. QC is equal to concentration of product square by concentration of N2O4 reactant. Okay, concentration is given 0.2 square by 0.16. Okay, answer is 0.25. Okay, so QC we got 0.25. We know Kc is already given in the problem 0.36. So we know both are different. So the reaction is not in equilibrium. Okay. Now, next we have to find in which direction the reaction proceeds. Here QC is less than Kc from the 0.25 and 0.36. Okay. So QC is less than Kc. Okay, so what we have to do? We have to increase the concentration of the product. Okay, then only this 0.25 reaches 0.36. So we have to increase the concentration of the product. So what we have to do? We have to proceed the direction in the forward direction. If the reaction proceeds in the forward direction, then only the product increases. So this means the reaction will proceed in forward direction. Proceed in forward direction.